Thanks, Alistair. Thanks, everybody. I got handed this on my way up, and it's a different representation of the food web in Lake Ontario. In the middle are alewife. Below it are things that alewife eat, and above it are things that eat alewife. So it's, I won't actually be talking a lot about our fish community indicators. They talk a lot about diverse preyfish communities, but if you're familiar with Lake Ontario, it's a very alewife dominated system. So that's, I think, one just different representation of how things look. Today I'd like to talk to you, we're going to focus on pelagic preyfishes in this talk, and then there'll be some more on benthic preyfish later, I guess tomorrow morning, right? The first thing I'd like to talk about is just give you a quick exec summary, and that's, we've established a preyfish working group, and really the most important things to think about from that, or the take-home messages, is we're actually suspending our targeted rainbow smelt survey this year, hopefully into the future, and we're hoping to do a lot more collaboration between our boats. We have multiple boats now. The OMNRF has a boat on the lake, and the DEC has a boat, USGS has a boat, so we're trying to pull resources and get at things in a more efficient manner. Alewife are basically, the densities around at about their 10-year average, but condition has declined. You saw Jim Hoyle hint at that with some of the relationships with walleye. And then we're also going to talk a little bit about reconciling our acoustic and bottom trawl surveys and the results from those two. So I'd like to start just thinking about sort of our working group concepts and talk about why we formed it. And really our lake is sort of the unit of interest, and we want to set up multiple data sets to help that inference. So instead of just getting up here, maybe you've been here for a few decades, seen a USGS scientist just talk about one side, or an OMNRF scientist just talk about another data series, we're going to try to put those together. And where they're different, we're going to try to learn something about that. We want to build on those time series too, where there are holes, try to fill that in and understand why, if they're disparate, what's that actually telling us about the system. Tim did a great job alluding to it. There's spatial differences out there, and we want to try to get at those. And finally, there are infinite question out there, but finite resources. Recognizing we might not always be able to do what we've always done and still do what people want to know. So how to kind of maximize the efficiency. And really, that efficiency, I'll just move right into thinking about our rainbow smelt. Here's our time series. There's three different lines up here representing rainbow smelt density. One is a targeted early spring, very early spring bottom trawl survey. That's the alewife survey in the thick gray line. A targeted rainbow smelt bottom trawl survey about a month later. And then also an acoustic survey. And really what they're telling us is very similar. There's a high correlation between any of those surveys. So, you know, could we have these other questions and these other research agendas, could we get at some of those by being a little more efficient, not necessarily sampling rainbow smelt as often? So many surveys, same answer. So we did just want to make sure, you know, I didn't want to be the person to change something and throw away a survey, and then, you know, 10 years down the road, people would be like, oh, that idiot, you know, why did he get rid of that survey? That was the critical piece that things would eventually change and we'd learn something about it. So we asked, how different are these two bottom trawl surveys? What are they really telling us? I was told that, you know, we trawl for smelt a month later because all the adult smelt are up in the tributaries. Well, I just looked at the average weight difference between the two surveys, and it wasn't actually bearing out in the data. The data didn't suggest that. We catch heavier and larger smelt when we go out in the springtime, in the very early spring. And so we just started to do some comparisons of our length frequencies between the alewife survey there represented in the dashed line and the smelt survey in the solid line. And what we see is that the alewife survey just tends through 2 years to catch more, on proportion, more larger smelt and miss some of those yearlings. So we wanted to try to get at a mechanism for why that was, knowing that there's some differences in where these targeted surveys are actually sampling in the lake. And so we wanted to look at sort of the mean depth of where we were collecting smelt. The red lines represent the mean depth of capture for smelt collected during the smelt survey for both yearlings and adults, while the blue line represents rainbow smelt caught during that alewife survey. And really what we started to understand was that a lot of that differences in what sizes of fish were being caught was simply a matter of where you were fishing. If you didn't have a high enough proportion of your toes, between 80 and 8 meters, you weren't going to get at a lot of those yearling rainbow smelt. So we answered the question, can the alewife survey equal the smelt survey? Yes, it can. We can save some time. We can assess them that way. We just have to add a few shallower toes. And in that way, we save some resources for some new questions. Excuse me. So now transitioning to alewife and getting at some of where we might put those resources, looking at just the status of alewife from our spring bottom trawl assessment, it looks like our 2014 numbers were right around about our 10-year average there, represented in the dashed red line. So we didn't see a big change in alewife densities in 2014. We did see quite a large change in our yearling index. So we don't have a great way of actually catching young of year to assess year class strength in a given year. So we collect yearlings that next spring and use that as our assessment of sort of young fish survival and recruitment to the fishery. And after the largest catch ever in 2013 of age 1 alewife, we actually got quite a small return in 2014. So low year class from the 2013 time series. This is interesting. Here we're mapping the trends in hydroacoustics noted there in the black diamonds and black triangles. And what you want to see is that they actually are following the trends that we see in our bottom trawl quite well, but the scales are quite different. In any given year, the bottom trawl will estimate that there's 40 times more alewife out there than the hydroacoustic survey will. And so this is sort of that elephant in the room that we're just like, man, we really need to work on this. We spend all our time doing other long-term surveys, we can't get at it. So this is what we're focusing on, and probably one of, I think some of the neatest work that's going on with hydroacoustics in the Great Lakes is thinking about sort of questioning our assumptions of what's happening with up-looking or traditional down-looking acoustics versus up-looking acoustics. What are you missing by driving those boat over those fish you're trying to sample? And this is work that Ted Shaner and Mike Connerton and Jeremy Holden are leading. And here on this side, you see what you would see. This is the number of alewife-sized targets in a depth bin with traditional down-looking. When you flip that transducer and you add this super tricky biosonic sub-DTX transducer and you run it, not only do you see about the same distribution, but you see these fish up here at the surface that you would never see in your down-looking. So this is where we're trying to get at, use our additional resources. This year, the USGS boat is actually going to be joining the acoustic survey, and we're going to be doing more of this kind of work. And here's the sub-DTX. And this thing's been deployed both on the bottom, so passively looking up, as well as from a tow fish and being pulled out and away from the boat. So a lot of neat work. And I actually think some of this might be recently funded for the Upper Lakes. Is that right, Dave? Okay. We mentioned alewife condition and how low it was. Here on the y-axis, we're showing the weight of a 165 millimeter fish and the time series for both spring and fall. And you can see, very similar to what Jim Hoyle showed in his walleye numbers, we had very high condition for quite a while. And in 2014, things were much, much lower, in both seasons. And so there might be some implications for thiamine deficiency. We've been hearing about that in terms of some of the predators and some mortality events that we're having. People are recording in Lake Ontario at this point. So with that, I'll just finish with a picture that there are still big bags of alewife out there. So when we talk about the food web, some of us kind of laugh and just think about, there's lots of these little silvery fish still out there that are dominating the system. And with that, I'll take any questions.